Unit 7, Rational Expressions and Equations. When we talk about rational expressions, we're talking about fractions. Rational comes over to ratio, which is something over something else. And these are basically fractions. And we simplify as we learned the exponents before. So example 1 here, 8x squared over 24x. What we have here is we have 8x squared in the numerator, 24x in the denominator. I like separating that out. 8 over 24 for the first part, the numbers, which say was 1/3. And then second part, x squared over x, which is x. So when I finally do this, what I get is 1/3 times x, or x over 3. Let's look at number 2 here. 5a plus 15 all over 10. I have a single digit in the denominator, 10, and I can reduce this. I can also pull off 5 of both of them. This is 5 over a plus 3 in the numerator. 5 times a is 5a. 5 times 3 is 15. In the denominator, I got 10, which is 5 times 2. 5 over 5 is 1. These two cross out. So all we're left with is the a plus 3 over 2, which is what I have right here. Example 3, 6a plus 12 over 7a plus 14. It looks more complicated, but in the numerator I can pull out a 6 out of that 6a plus 12, and that leaves 6a plus 2 in the numerator. And then pull a 7 in the denominator right here, and 7 out of 7a plus 14 leaves a plus 2 again. A plus 2 over a plus 2 is the same as 1 over 1. Anything over itself is always 1. All I have left with is 6 over 7. Now we can also multiply these. Let's multiply 5a cubed over 4 times 2 times 5a. 5a cubed times 2 down here is 10a cubed. And in the denominator, 4 times 5a is 20a. And 10 over 20 is the same as 1 over 2. And then a cubed over a is the same. I subtract an a, right? 1 right there. A squared. And it's 1/2 times a squared, or simply a squared over 2. Those are some problems here. Simplify 4x squared over 20x. 4 over 20 is the same as 1 over 5. X squared over x is the same as simply x. So it's 1/5 times x, or x over 5. Now example 2 looks more complicated, but not really. We've got to remember our factoring components from before. T squared minus 25 over t squared plus t minus 20. This first part is a difference of squares. I got a perfect square into t squared and a perfect square with 25, and subtracting them. So this is simply t plus 5 over t minus 5. And I rewrite it. And the denominator, if you recognize, we can use the PQ method, but this is pretty simple. T squared plus t minus 20 is the same as t plus 5 over t minus 4. Well, now I got a t plus 5 numerator and a t plus 5 denominator where I'm multiplying them against each other. Those cancel out, same as 1. So my final answer is this is what's left, t minus 5 over t minus 4. Now division, we talked about this before with fractions the same way. We simply flip the second rational expression. X plus 1 over x plus 2 divided by x minus 1 over x plus 3. We're going to simply find the reciprocal of that second expression. So from x minus 1 over x plus 3, that becomes x plus 3 over x minus 1. And I multiply all this together. This times this gives me this, x plus 1 times x plus 3, and this times this gives me that. And there's nothing we can do with that equation right there. Same thing here. X squared minus 2x minus 3 over x squared plus minus 4 divided by x plus 1 over x plus 5. I've just flipped these two over here. So now it's x plus 5 over x plus 1 here. And now what I'm going to do is I'll multiply if you notice this, what I did here and factored here, in this first expression, x squared minus 2x minus 3 is the same as x minus 3 over x plus 1. Use the PU method. And here's another difference of squares. X squared minus 4 is x plus 2 times x minus 2. When I multiply all these together, I end up getting x minus 3 times x plus 1 times x plus 5, which is all right here. And then the denominator, x plus 2 times x minus 2 times x plus 1, right here. And there's two x plus 1s, they cancel out. So I'm left with what's left over. X minus 3 times x plus 5 all over x plus 2 over x minus 2. Now here's some examples here. X squared over y divided by x cubed minus y cubed. I'm just flipping the second expression over, so now it's y cubed over x cubed, which is because I'm multiplying by the reciprocal. And I'm getting x squared times y cubed plus x cubed times y. And what cancels out here is I got a x squared over x cubed. That just would eliminate everything here, just leaving an x. And then y cubed over y is simply y squared. And that's what we have, y squared over x. Second one, x minus 8 over x plus 9 divided by x plus 2 over x minus 1. I multiply the second part by the reciprocals. I'm going to flip those over right here. And then when you multiply this out, there's nothing you really do. It ends up just being all these components multiplied together. X minus 8 times x minus 1 all over x plus 9 over x plus 2. And the third one, x squared minus 9 over 4x plus 12 divided by x minus 3 over 6. And what I have here, as I said before, this is a difference of squares. So I've sorted it out by factoring. So it's x plus 3 x minus 3. I flip the x minus 3 over 6 over since I'm dividing. Now it's 6 over x minus 3. And what I've done here, 4x plus 12, I can factor out a 4 out of that, leaving x plus 3. So when I multiply all this together, I get x minus 3 times x plus 3 times 6 over 4 times x plus 3 over x minus 3. The x minus 3's cancel out. You can see here and here. The x plus 3's cancel out. And I'm left with only 6 over 4, which is the same as 3 over 2, or 1.5. Now, one of the things we want to do is when we have these complicated fractions, especially in the denominators, we want to find the least common multiple. And you always think, I'll just multiply one denominator by the other. That can get pretty hairy. What we can do with the least common multiple is find the earliest common point if we multiply them both out. And what we do is we get on down to the basic levels. In terms of numbers, we get the primes, and in terms of the variables, we get the single letters. So get the least common multiple, 24 and 36. 2 times 2 is 4, times 2 is 8, times 3 is 24. And these are now those primes. And then 36 is 2 times 2 times 3 times 3. And I've got 2's in both of them, but I'm going to pick 3 2's here since there's 3 2's right here. There's only 2 2's right here, so we don't use those. And then I see some 3's. Well, there's only 1 3 here, but there's 2 3's here. So I use those right here. So 2 times 2 times 2 times 3 times 3. 2 times 2 is 4, times 2 is 8, times 3 is 24, times 3 is 72. And that means the least common multiple for 24 and 24 and 36 is 72. Because you go 24, 48, 72, and then 36 and 72. Use the letters. 12x would be 2 times 2 times 3 times x. 16y is 2 times 2 times 2 times 2 times y. And then xyz is x times y times z. I've got 4 2's here. I've got 2 2's here, but that's not enough. We're using the ones that have the most right here. I got a 3, only 1 3 here. I got an x, a y, and a z here. And so since there's the same amount here, I just cross those off. So the least common multiple for all 3 of those variables is 48x, y, z. And then even with factored components, we can do that. Least common multiple, x squared minus 25 and 2x minus 10. x squared minus 25 is a difference of squares, x plus 5 over x minus 5. 2x minus 5 is 2 times x minus 5. They both have an x minus 5 here, so I'll use this one, it really doesn't matter, cross this one off, and I can use the x plus 5 here, there's that's left, and there's a 2 left. So least common multiple is 2 times x minus 5 over x plus 5. Now let's look at least common multiple for 24, 36, and 40. 24 as we did before is 2 times 2 times 2 times 3. 36 we did before is 2 times 2 times 3 times 3. And 40 is 2 times 2 times 2, which is 8 times 5 is 40. And I got 3 2's here. There's 2 2's there, and there's 3 2's there. So we'll use the number of 3 2's, that's the most. And I've got 1 3 here, and I've got 2 3's here. So we'll put 2 3's there. And I've got 1 5 left over, so we better put that somewhere. Put it right there. And 2 times 2 times 2 times 3 times 3 times 5 is 360. You can multiply these all out. 24, 48, 72, 96, 120. It goes on 36, 72, 108, and 40, 80, 120, 160. Keep going. Well, much easier to do it this way. They're going to have a common multiple at 360. Do it much quicker that way. These common multiple of x squared minus 4 and x squared minus x minus 2. This is a factoring part. X squared minus 4 is difference of squares. It's x plus 2 and x minus 2. X squared minus x minus 2 is x minus 2 and x plus 1. Well, both have an x minus 1 there. And then this one has an x plus 1. The second one is x plus 1 right there. And I got an x plus 2 minus over. Those three binomials together, when multiplied, become the LCM of those two expressions. And we use this when we're adding rational expressions. Let's look at 3 over 8x plus 5 over 12x squared. Well, these common multiple 8x, let's multiply it out, is 2 times 2 times 2 times 8. This common multiple 12x squared is 2 times 2 times 3 times x. And I've got 3 2's here, so we don't use those there. That's that. We got 1 3 left over right there. And we got 2 x's here, and that crosses that off. So the least common multiple is going to be 2 times 2 times 2 times 3 times x is 24x squared. So I need to have common denominators, as we learned in our first chapter. 3 over 8x equals what over 24x squared? Well, I can multiply by itself, and any number over itself is 1. Now I'm going to use 3x's. 8x times 3x gives me 24x squared. But if I'm going to multiply by itself, because we want balance, this is algebra, it's 3x in the numerator, 3x in the denominator. So 3 times 3x is 9x, 8x times 3x is 24x squared. There's our first part right there. So there's the first one. Second one is 5 over 12x squared. How do I go from 12x squared to 24x squared? I'm simply going to multiply times 2. But since I'm multiplying, I can't change it. It's 2 over 2. 12x squared times 2x, 24x squared. There's my same denominator. And 5 times 2 is 10. So the answer is, the second expression is 10 over 24x squared. So my final answer is 9x plus 10 over 24x squared. Now here's another one. Add 2a over a squared minus 1 plus 1 over a squared plus a. Well, least common multiples for the a squared minus 1 that's a difference of squares, so it's a plus 1, a minus 1. And the second one is a times a plus 1. And really all we need to do is, let's see here, I need to add an a minus 1 for the second one right there. They both have an a minus 1. There's an a plus 1 in the second part and an a in the second part. Cross out the other a plus 1 because it's the same. So I need to go for the first component, a squared minus 2a over a squared minus 1. It's got to equal, I got to multiply times something to get a over a plus 1 times a minus 1. Well, the only thing I'm missing here, a squared minus 1, because that's a plus 1, a minus 1. We add the a here. Well, To get there, I just need to multiply everything by a over a. Now I'll just leave it like that. 2a times a in the numerator is 2a squared. So there's my first part, 2a squared over a times a plus 1 times a minus 1. And then my second rational expression is 1 over a squared plus a. And I simply need to convert that second one by multiplying times an a minus 1. So a minus 1 in the denominator, I get the same expression as in the other denominator. So now we have same denominators. And then I got a over a minus 1 times a over 1 is 1. 1 times a over 1 is a over 1. It's multiplying by itself. So my final answer is going to be 2a squared over a times a plus 1 times a minus 1 plus a minus 1 over a times a plus 1, a minus 1. And this is the final expression. And there's nothing we can do. Now, let's look at 13 over 18x plus 7 over 24x. Well, least common multiple for the 18x is 24x. When I go through 18x, that's 2 times 3 times 3 times x. 24x is 2 times 2 times 2 times 3 times x. And I got 3 2's for the greatest number of 2's, 2 3's, the greatest number of 3's, and there's 1x, so it's 72x. So I need to go for 13 over 18x to what over 72x? Well, that's 4 over 4. 13 times over 18x at 4 over 4 is 52 over 72x. There's my first part from over here. And my second part, 7 over 24x to get 72x, I'm simply multiply times 3 over 3. 24 times x is 72, times 3 is 72x, 7 times 3 is 21. So 21 over 72x, and there's the second part. And 52 over 72x plus 21 over 72x is 73 over 72x. It's our final answer. Now add and simplify. 8 over y plus 3 squared plus y plus 5 over y plus 3. And I'm looking at this. We can leave this first expression alone. It's y plus 3 squared because the second one's just y plus 3. I just need to multiply a second expression times that y plus 3 over y plus 3. So we're going to leave the first one alone here because we got y plus 3 squared. Now the second one, we need to multiply the 5 over y plus 3 times y plus 3 over y plus 3. Again, y plus 3 over y plus 3 is 1. We're just changing the identity of it. 5 times y is 5y, 5 times 3 is 15. So it's 15y plus 5y plus 15 over y plus 3 squared. And there it is right there. So when I add this all together, 8 plus 5y plus 15 is 5y plus 23 all over y plus 3.